so now we're going to evaluate. And just so that you're clear, whenever you see the word evaluate in math, the root word is value. So you're going to simplify it to give me an answer. Okay? So this first one says log base 8 of 64. And you're like, oh my gosh, I have no idea what that is. So what you're going to want to do is say that that equals an exponent. So I'm going to call it x, right? So really what we're going to do is put it in a more familiar form. So I'm going to switch to exponential because I've been learning that a lot longer than I've been learning logarithms, and so our brain will pick up that pattern better. So we have 8 to the x equals 64, right? And I know you guys all know this is 2, but as the problems progress, this is the way that I want you to think about them. So what we're going to try and do is like we did in the previous chapter, we're going to try and get these written with the same base. So how can I write 64 as base 8? Oh, that's 8 squared. And now we're doing that thing where we go, well, if the bases are equal, the exponents must also be equal. So the answer to this is 2. Now you notice I didn't write x equals 2, and if you do it, it's totally going to be fine. But in the original problem, I wasn't given an x. I used it as a tool to help me solve. So the final answer shouldn't have an x because it really wouldn't make sense. Like right here, if I wrote x equals 17, which is not the answer, but hypothetically, say if I wrote that, somebody might look at it and go, where did they even get the x from? So that's why I didn't write it. But since this is your first time seeing logarithms, obviously a little thing like that in notation is not going to be marked down for you guys. So this one is saying 3 to what power equals 27. So again, trying to keep in mind, how do we get those with the same base? Okay, so that would have to be 3 to the 3rd power. Because the bases are equal, we disregard them. They already meet equal sign. It's these guys. So the x value has to equal 3. So the exponent, 3 to what power is 27, is 3. So some of you will start to do this without having to use this trick, but we always show it this way because when they get more difficult, it's easier to look at it that way. So like this one, logarithms are equal to exponents. So you're saying 6 to what power is 1. So a lot of you can go, oh, anything to the 0 power is 1. Okay, so if I'm doing the math for that, if I'm translating it to exponential, you can see it. All right. Let's move this. So we have 25 to what power equals 5. Now, you know 5 squared is 25, right? But that's not what this is asking. So again, we're going to change the bases. So I can't change this base because this is 5 to the 1st power, but I can change this to 5 squared. But then there's still the x. Properties of exponents say we multiply those. Okay? Because the bases are the same, the exponents must also be equal. So then divide by 2, divide by 2. So if I raise 25 to the 1/2 power, it'll give me 5. Which makes sense because we learned in the last chapter that if you square root a number, it's the same thing as raising it to the 1/2 power. All right, let's try the next one. We have 8 and 2, so 8 to what power equals 2? Okay, so this is 2 to the 1st power, so I'm going to write this with base 2. So 2 times 2 times 2, so 2 to the 3rd power equals 2 to the 1st power. And then property of exponents say to multiply those. So I can get rid of the parentheses by just writing it as 2 to the 3x. And then because the bases are equal, the exponents must also be equal. So the answer to this one is 1/3. All right, let's do the next one. 4 exponent to what power equals 1/64. Okay, so again, same thing over and over again. We got to try and get these written with a base that's the same. So 4 to the x equals 1 over 4 cubed. But I can't stop there because this is in the denominator. So we learned in the last unit that if you want to move it up, you just change the sign of the exponent. So that's 4 to the negative 3. Now because the bases are the same, the exponents must also be equal. So we get x equals negative 3, so the answer is just negative 3. This is called a reciprocal power of 4 because 4 to what power is 64? That's 3, but because it's in the denominator, it's a reciprocal power. Reciprocal powers are always negative because you have to move them from down below up to the top. Just a fun fact, nothing you need to have memorized. Okay, 1/5 to what power is 25? Okay, so first thing I'm going to do is I'm going to get this and write it as 5 to the negative 1, right? Because there's a 1 there and I'm just moving it up. And then this is going to be 5 to the negative 2. Not negative, just 5 squared. Sorry about that. Okay, so then I do the power to the power, so that's 5 to the negative x equals 5 squared. Because the bases are the same, the exponents must also be equal. So I'm just getting the x by itself. So my answer is negative 2. Okay, moving on, we have this guy right here. 81 to what power equals 1/3. So this is your clue right here. You could actually use a base of 9, but that would be really intense. So I'm going to change this to 3 to the negative 1, and then you can use your calculator to figure that this is 3 to the 4th power. Okay, again, power to a power, you multiply. 3 to the 4x equals 3 to the negative 1. And then because the bases are the same, the exponents must also be equal. Divide by 4, x. Whoops, I'm not going to put that. You get negative 1/4. Pretty cool. Alright, let's do this guy right here. 2 to what power equals negative 4. And you're like, So this is where I'm just going to pause for a second and talk about logarithms just a little tiny bit, a little bit more, and give you some background. Okay, so we know that 2 to the 0 power is 1. And we know that 2 to the 1st power is 2. 2 to the 2nd power is 4. 2 to the 3rd power is 8. Okay, so all of these right now are positive numbers, right? But this is saying 2 to some power is a negative number. So let's look into our negative. 2 to the negative 1 is the same thing as 1 over 2 to the 1st power, which is 1/2. Okay? 2 to the negative 2 is the same as 1 over 2 to the positive squared, so that's 1/4. So do you think that we can ever get, no matter what exponent we put here, are we ever getting a negative number? And just to remind you, this is an exponential growth graph that's going like this, and there was this asymptote. So no matter how negative we go in the x direction, we're never getting negative y values, and that's what that is saying right there. So this is actually undefined. You cannot make that work ever. And so just write yourself a note that the argument of a log cannot be negative or 0, actually. So take a look at this. As we're going through, are we ever going to reach 0? Because 2 to the negative 3, 1 over 2 cubed equals 1/8. So we're getting closer and closer to 0, but we can't ever actually equal 0. Okay? The next one, 5 to what power equals 5? Well, this one, I guess we saved a pretty easy one for last. That's really just 5 to the 1st power, so the answer is 1.